We're going to handle cosine just like we handled sine. We're going to see that we have the looping in a very similar manner. We start with our function as cosine, which derives to the opposite of sine, which derives to the opposite of the cosine, which derives to sine of x, which derives to cosine of x, which brings us back to where we started. When we plug in 0, cosine of 0 is 1, sine of 0 times negative 1 is 0, cosine of 0 is 1 times negative 1 makes it negative 1, sine once again is 0, cosine once again is 1. All right, so let's put it all together. Cosine of x. All right, our first term is 1, all right, f of 0, plus f prime of 0 times x, so we have 0 times x here, plus, now we have negative 1 is our coefficient, all right, we need x squared, and it's got to be over 2 factorial, plus, now we need our x cubed term, which is going to be 0, plus, now we need our x to the 4th term, so that's going to be 1 times x to the 4th over 4 factorial, plus, so on and so forth. Simplifying it up, cosine of x is going to be 1 minus x squared over 2 factorial, that's a factorial right there, sorry, all right, plus x to the 4th over 4 factorial, minus x to the 6th over 6 factorial, plus so on and so forth. What's the actual general term going to be? Well, we still want our first term to be positive, so we're still going to have our series needs to alternate, so negative 1 to the nth, right? And then this time, it's x not to the 2n plus 1, but just to the 2nth, all right? And we're going to divide by that 2n factorial, all right? So when we plug in 0, right here, all right, x to the 0 is 1, 0 factorial is 1, negative 1 to the 0 is 1, 1 times 1 times 1 gives us 1, all right? When our first term, when n is 1, all right, we have negative 1 to the first power, which is a negative value, so it matches our minus. Then we have x to the 2 times 1, or x squared, and then 2 times 1 factorial, 2 factorial. And that will continue on and match the way that we need it to.